Water rises in a capillary tube to a height of 2.0 centimeter. How much will the water rises to another capillary tube whose radius is 1/3 of the first tube? Good. The formula is H equals 2t cos theta upon rho g r. Let us learn each letter what it stands for. The H is the height of the liquid rises through the capillary tube. Then the T is the surface tension of the liquid. Theta is the angle of contact. Then rho, the density of the liquid. Then G, acceleration due to gravity, equals 9.8 meter per second square, and R, of course, the radius of the capillary tube. Here, the height depends on the radius of the capillary tube because the rest of the term in this section is constant. The first term, surface tension of the liquid, is constant, and the angle of contact is constant. The density of the liquid is constant. Then acceleration due to gravity is constant. So the height of the liquid rises through the capillary tube. H inversely proportional to the radius of the capillary tube. So H proportional to 1 upon R. So we get HR equals a constant. This formula we are going to use to solve the problem. H1 R1 equals H2 R2. What we are going to find is H2 equals H1 R1 upon R2. The H1 is given equals 2 centimeter. R2 is given which is equal to 1/3 of R1. We are going to substitute these values here in the formula. And please don't bother about the centimeter to meter conversion. The final answer will be available in centimeter only. So we get H2 equals, in the place of H1, we write 2 centimeter. In the place of R1, let it be R1. In the place of R2, let us write 1 upon 3 times R1. R1 is getting cancelled. So we get H2 equals 3 times H1. The H1 is 2 centimeter. So 3 multiplied 2, we get 6 centimeter.